Man, that was a mess. Sorry, everybody. Welcome to our first Monday morning metrology. Even though our test broadcast, we had no issues. And then here, we thought everything was great, everything was looking good, and everything was trash. But here we are. Good morning, Joseph. How are you? How was your weekend?
Yeah, it was good, hot, and
Hot.
yeah,
100 degrees.
yeah. You guys had some smoke.
What do you mean, smoke?
You don't have a big fire up there?
Oh, yeah. Yeah, there is. And so 100 degrees, 37.778 degrees Celsius for our worldwide viewers. Yeah, it's been a hot one with everything going on. I even I think you know, Joseph, that I like barbecuing
Yeah.
and this has to do with temperature right here. I got a smoker, one of those pellet smokers, and for those of you purists, I did it for 12 years the normal way, a stick burner. I'm done with that stuff. I do a pellet smoker now. But when I went out to set up my smoker, it was about 2 or 3 in the afternoon because I was just doing a couple tri-tips and putting those on for dinner. With me just turning it on, it was 120 degrees inside my smoker just because of the insulation and it being inside of all of that and with 100 degrees outside. I mean, what a burner, huh?
Yeah. We don't mean pellets.
So first topic I wanted to talk about this morning was last week I mentioned I was going to be going into that educators workshop or the educators committee meeting for
Yes, sir.
NCSLI. And I called you directly after because I had a really good time. I think it's for those that don't know, we also do a podcast, Metrology Today. And we've talked with numerous people that have mentioned, getting involved in these committees, getting out there and meeting like-minded people. That's really one of the things that I took away from it is it was nice to be surrounded in a conversation with people that are interested in what I'm interested in and have the same idea, the same general goals and focus in metrology, training that next generation of metrologists, the next generation of technician, whichever it may be.
Yeah, I think that's an important aspect of what we do. I was traditionally trained, so I had a mentor and I came up through the ranks that way. So
Right.
our training system seems to be just lagging a little bit behind or missing some things.
The industry, you mean?
Yes.
Yeah. Well, it went away for a while. And for those of you that are newer and don't understand the field or you're just starting out, don't worry. This channel is going to be devoted to metrology, getting people interested in the field and understanding more about what we do. We even have some documentaries, some really cool series that we're going to be releasing this summer where we focus on different cal labs and manufacturers that do wildly different things. I mean, our very first episode is a company that focuses on high frequency calibrations, things up to, oh, I didn't think I was going to talk about it, but I think they're up to like 60 gigahertz or something there. It's just wildly high. When I was in the Marine Corps, we went up to 26.5 at the most usually. Towards the end of my career, there were a few things that would come up to be like 40 gig, but I think these guys were up to 60 or 80 gig. I mean, something really crazy. But I got to go visit there, see their EMC chamber, and they help out a lot with people working the towers for 5G. So that's a really interesting application of metrology. But then the episode after that, we're going to more physical type things, force, and visiting with Morehouse in York, Pennsylvania. And how would you describe force?
Force is very mechanical.
Yeah, mechanical. And
So
it has to be aligned very well.
yes, yeah, that's one of the aspects that people fail to understand. They think, oh, I'll just stick something in here to make it fit or adapt. And there's not, Henry Zunberg goes into a big discussion about adapters and stuff. And I think his stuff is really something people need to listen to.
Yeah, for sure. Yeah, so then we visit for Morehouse, and we're also looking for more places. If you want your lab to be featured, or if you have something interesting going on where you work, reach out to us at information at signcalibration.com. That's where we can feature you guys, talk about what you do. I'm all about the field, seeing what technicians do, showing future technicians or people that are maybe thinking about it. This is a career path. And I'm glad they brought this up in the NCSLI meeting. This is a career path that can be done. You can become very successful without going to college.
Oh, yeah. Most assuredly.
Well, and there's only a few metrology programs in the country right now that are even teaching, that even focus on metrology. Now, of course, there's physics programs and all that around the country. And physics is a lot of what we do, but sometimes that application in the form of calibration, in the form of metrology, is where things get tricky.
Yeah.
So go ahead.
No, I was going to say, they teach physics, but they don't exactly teach the nuances of metrology and the things that we do and why we do them.
Right. Or some of them are specific. They're around automobile manufacturers, and they teach a very physical dimensional based program. They don't have much need for that higher frequency stuff. Or I don't know enough about those programs, and as I find out more about them, I'm hopefully going to get some of them on to one of our programs, either this or our podcasts, where they can talk about some of the things they cover. I don't know enough about them to talk about it. So I was also in preparation for today's show, I was taking a look over the last week of the metrology but the metrology group on Facebook. And this week was a week of the 20%. I mean, there wasn't too much of anything really groundbreaking coming through, or anything major, except for one question. It was geared around flow and for a doctor's office. And I don't know if you saw that one, Joseph. Did you happen to see that one?
No, I didn't.
But people were talking about, he's asking, what for this flow meter specifically for a doctor's office, what's the procedure? And luckily there were a few that were like, hey, your company needs to be insured for that. That's a very specific thing that you have to mention to your insurance company, saying that you're going to be working on things that touch patients. You know what I mean?
Mm-hmm.
And, that goes into a conversation you and I have had for a long time, where I really like the forums because we get to reach out to one another and we get to talk about some of the challenges we're facing. But then outside of those ones that we're, giving caution to this person asking random strangers for help, although we are in a group, but then there's others just giving just random suggestions. And I have talked about this so many times, where you're coming into a Facebook group where you're getting advice from who knows, and of course you can see the advice given and do some reverse research on, who they are and what they're doing. But even some of the smartest guys in the group are super sarcastic, and if you aren't picking up on that, you could be doing something majorly wrong.
Mm-hmm. Yeah, I think it's imperative that the people in our field and in the group understand the significance of what we're doing and why we're doing it.
Right. And the liabilities and risks.
Oh, yeah.
But I understand how these guys work. They come into it, they have a job, they just want to get their job done. Or, a customer comes in saying, I have this challenge for you, and they just want to solve that challenge. That's the other thing.
Yeah. I one of those things about us as a community is we're very cavalier and nonchalant about a lot of things, because in our given environment, we succeed and we do well. But like you said, there's so many different disciplines and aspects to what we do I can recall one time I was sitting in my laboratory, and gentleman, this was working for the Navy, came in and he had a pin that he needed to solder onto a wire. Now that temperature was from the manifold of the airplane. And so it gave a direct reading back into the cockpit of what the manifold temperature was.
Hmm.
Without it, there's no way to know.
Wow. Yeah. So my question for the community, anybody that ends up watching this, whether you're in the school or wherever this is connected, if you watch this afterwards, is there a place for a technical forum for serious questions only? That how that all started was that guy, that made the comment, 80%, we should focus 80% on serious things, 20% on humor. And, you can't tell a group of calibrators that type of stuff. But with that, is there a place, should we open up a forum where we as the school moderate it? What's your opinion, Joseph? Do you think we should open up a forum inside the school for questions like that? My only Let me preface with, my only hesitation is I don't like people asking for procedures. There's just too much to know before saying, "Hey, use this procedure."
Oh, yeah, most undoubtedly. I think we should have this forum. I mean, we should keep it and nurture it and grow it to something that really, really is good. And as far as the latter part, people asking for help, it's always concerned me. You know that
Right.
because we both worked in quality assurance and technical management and lab operations. And one of the things that I dread is people saying two things. That's the way we've always done it. Or, well, I talked to my friend in Rota, Spain, and he said to do this. The you cut yourself completely out of the loop with your laboratory and the operating procedures, the scope or SOPs, quality manual, whatever you have in place. It's you just really need to check with your people in your lab.
Right. Well, and that's how we teach things is, yeah, we might be using, something from Sika, we might be using something from Aditel, Fluke, so on and so forth. We're just showing you behind the measurement. We're not saying, "Hey, now press this button, now press this button, go to this test point, go to this test point." You got to have
Exactly.
conversations before doing that stuff.
Exactly.
All right. Well, so we're hitting about 9:30. We're going to be doing a little bit of work here for our temperature training for 2021. We're going to be showing how we're going to be talking a little bit about, man, I can't talk this morning. We're going to be talking a little bit about temperature sources, specifically dry wells. So I have here in front of me, for those of you watching, I know there's a few that are listening in audio. I you We're going to try and get more information out there for people on ways that you can watch us and the ways you can communicate with us. But there is a way you can listen to audio only. But for those watching this live, so in my hand, I have an insert for a temperature well. So what we're going to be showing today is basics around a temperature well, the things that you need to think about, why temperature sources are important. And then we're going to be talking a little bit about using them to test type K thermocouple. We're talking about thermocouples right now, coming up here in the online portion. So this is leading into that training. So just give me 1 second to set up that demonstration, and we'll be right back. Sound good to you, Joseph?
Yes, sir.
Okay, so this should be only just a minute or so. All right, so we're back. Here, let me go back to my normal camera real quick here. All right, so I'm back. I'm going to go over to our demonstration table. We're going to start talking about temperature sources. So here is a temperature well. Okay, there we go. Sorry about that. Okay, so here we got a dry well. Now this is going to be the most common that you all see out there. Here, let me go full screen for them, Joseph. You can still
Sure.
see what I'm doing. Okay. So this one's by Sika. Now, I want everyone to keep in mind, we are not sponsored. We haven't been paid, but this was donated to us. But it was with no strings attached. We don't have to say it's great or anything. They just wanted to help out the school. So we really appreciate that, Sika. It's the same thing with Aditel. They don't pay us in any way. They've just been really helpful to us in the course. So thank you to both of those. So a dry well is going to be the most common. Now, when we're testing thermocouples, obviously you're hoping you can actually get to the thermocouple. Very rarely is it going to be as simple as just having a nice little probe, like this one here, where you can just stick it in the well and do a direct readout. If you're on site, a lot of times the probe is going to be inside of something, right, Joseph? Have you done a lot on sites?
Oh yeah. It's very rare that you can get them all out, and later we'll explain, how we use a pi calibrator, the little thing that emits voltage.
Yeah, for simulating.
Mm-hmm.
So this method here is using the dry well, and here's that insert that I was telling you guys about. Now that just slips right in the middle here. Now, the trick with a dry well, and the thing to keep in mind about these, is that insert had 2 holes, this particular insert. So that means it can only fit, here, I'll even pull it back out here so that you can. So looking in the top, this particular one only has 2 holes. So you're only going to be able to fit a temperature sensor that will fit in one of those sizes. And really, you don't want much air gap. You want to have room for expansion, because most of the time you're going to be calibrating heat. Although there are temperature wells that go into negative temperatures. This one does as well. But the important thing to realize is that you need a little bit of space for your probe, but you don't want too much where air is insulating the probe. Right, Joseph?
Yes.
Air is a horrible insulator when we're doing calibrations. Horrible insulator. So as you can see, I can just insert my probe into the well. And so that is one of your first considerations. The hole size. There are ones of these. Sika sells ones that has a little insert that you can put in here for a stirred liquid bath. I really, really want them to hook me up with a demo model of that to show people. I've been on so many on-sites that it would be nice to have a stirred liquid bath with me.
Yeah.
The benefit of the stirred liquid bath is that it will fit almost any size. It will fit odd size temperature sensors. You might have ones that are built into little nozzles or whatever, and they're not going to fit in any hole, right? Mm-hmm. So that's why you have to have stirred liquid bath sometimes, and those traveling is not easy. So it's very cool to see something like this in this package where you just would slide in a liquid bath. So I just wanted to mention that. So what are some of our other considerations with these? We want stability, right? Because stability of the temperature measurement. Knowing that if we set it for 20 degrees, it reaches and achieves 20 degrees or 100 degrees, whatever it is, that it will stay there and give us a stable measurement, right?
Mm-hmm.
So here over to the side, this is a Eurotherm, like many of you will see. I've got to get this so you can see it. There you go. Can you see that okay, Joseph?
Yes, I can.
So a Eurotherm like this is one that you're going to see very, very often in a process in manufacturing. Now, of course, a readout for temperature could be anything. It could be inside of a screen of a computer that's attached to a molding machine. It doesn't have to be all the same, but the principles are all the same. Those in our course know, they have seen this one demonstration wise, but you have inputs on the back. But a lot of times all you're going to see, like this will open up into, like it will have some sort of case. What are those called, Joseph, when you're on site? Like a like
Uh,
like it will be like a cabinet. That's what I meant to say, a
oh,
cabinet.
cabinet, yeah,
You know, this will be in a cabinet, and you actually
or a
have to
rack,
open it,
yeah.
or a rack, yeah, and you'll have to actually open it up and access the back. Or if you can test through the thermocouple, here I did with this one where we have. Sorry if you can hear me. On this one, I did it where we have just it hooked up to the back is just the female version of the K-type thermocouple. The reason I did this is mostly educational, but really you will see this on site as well because they will have switchable thermocouples, you know, where they don't just use one thermocouple. They might switch ones out every week or something. I've calibrated at places that they're hitting such high temperatures that they know exactly how long they can trust a thermocouple. So that's when you'll have, you'll have a quick connect like this in there in your cabinet or closer to the process. Now, if you are simulating, like Joseph was talking about with like a Pi or maybe a documenting process calibrator, you're going to want to simulate right into here, right where the closest point that the thermocouple plugs into, basically. Is that right, Joseph?
Yes, sir.
Because when you're simulating, all you're doing is replacing the thermocouple and you're testing that readout. So in this case, we can just plug this in. I have the thermocouple we already added, and then its connector, and we just plug it in.
And we know what input to do because we have the ITS 90 that tells us, temperature, voltage.
So let's see. Can you see that all right? So we're seeing 20.3 right now. And the drywall is saying 20.5. So let's go ahead and go to a temperature test point just so everyone can see. So when you're using a drywall and you're on site, typically a customer is going to say, hey, I want this tested at this point, this point, this point, or they could leave it up to you and you just ask them what ranges they usually use. But in this case, I'll just say, hey, we're going to test this at 100. What's nice is they have little buttons here where I can just put it in upside down. Okay, set test point, check. Okay, check. And then let's start. So as we're talking about this here in a minute, this is going to jump up to 100 degrees Celsius for its first test point. So some of the other things we want to talk about with drywalls. And here I'm going to switch over to the normal camera real quick. Okay. Here, Joseph, I'm going to bring you back in. You there? I can't hear you.
You hear me out?
Yep. Okay, there we go. All right. So what are some of the other factors we need to think of with a thermocouple? I have some of these pulled up on my phone. I mean, not with a thermocouple, with a dry block. So obviously, any temperature source you want to think of the ranges. What's the range of your temperature sensor? What are the ranges your customer needs? A lot of in the design of these dry blocks, they typically will have a really accurate thermocouple or RTD of them for themselves in there. So you're kind of dependent on the accuracy of that thermocouple, but also the intended range where you need the most accurate measurements. So what am I saying there? One like this that I have goes from negative 35 to up to 165 degrees Celsius. So I can use that to calibrate a lot of different RTDs or thermocouples, as well as thermistors. That's a very common temperature range for thermistors as well. But if I wanted to test a Type K thermocouple up to 1200 degrees Celsius, that's probably not the best drywall for it, right? We're going to want something that's more designed for that temperature range that I need. Now, unfortunately, it is the case, and I have had to do it. There are times you have to take multiple wells with you, or use multiple wells if you're doing it in the lab, right, Joseph?
Yes.
I mean, that's how things work. Unfortunately, you have to do what you got to do. So this one in particular that I have over here from Sika has a general accuracy of 0.2 degrees Celsius, plus or minus. And the stability, remember we were talking about the stability, is 0.01 degrees Celsius. So it will stay stable for a long period of time. And that's one thing I like about the Adatel one as well as the Sika one, is when you look at these, here, I got to pull this up a little closer. You'll notice that, well, you can't see it right now, is once it hits the temperature on the left there, that white block, that will start graphing how long and the variations that have been there. I like being able to see how stable it has been while I've been maybe doing other things. If I'm on site doing temperature, a lot of times I'm setting up my test point, and then I'm going to do something else, maybe a scale somewhere, or whatever, whatever the other things are that I'm doing for that day. So it's nice to have something like this where it graphs it for you, or like the Adatel ones will tell you how long it's been stable for. The graphing is nice because you can see if you had any wild dips while you were stepped away or you looked away. It wasn't until I started the school that I started seeing some of these really nice ones, Joseph. Did you have anything like this that graphs anything?
Oh no, not in the school. In fact, I don't even think we had a dry well back then. But the recent advances and stuff, and like you said, I worked at my last laboratory. I worked at a large industrial complex that had tons of thermocouples. So sometimes it wouldn't be unusual for us to take 2 or 3 dry wells with multiple chambers. And those sleeves that you're talking about, we've had sleeves that have 5 or 6 holes in them, so you can put multiple items in there.
Oh yeah.
And that's where the stability comes in good.
Right. Well, the thing is that that's a good thing to bring up as well, though, Joseph. If you do have one with many different probes, you have to watch for that load with them in there. Or if you add in a test probe that's freezing cold, people sometimes don't think about that stuff. Putting your probe into a well or into maybe your stirred liquid bath, and it's cold itself, you have to give it some time to stabilize after you have made any changes to the measurement environment.
Yeah, we would always warm ours up in another bath, or another well before we never put a cold item into a hot dry well. It's just
right.
Good practice.
Exactly. Yeah. So it looks like it is sitting at close to 100. Yep. So right now, we're at right around 100.04. But notice, everybody, how even though our thermocouple is a fast reacting temperature sensor, it's taking a minute because it's in a probe, and the entire well needs to come up to a stable temperature before we're expecting to see a perfect reading here. So this is a great example, Joseph, of why you need to use stabilization time, why you need to take time, plan for time when you're doing temperature measurements, right?
Oh yeah, because the heat sinks to a colder item. So if you put something cold next to something hot, it's going to sink across, bring the cold item up. So you're going to lose some of your stabilization.
I was going to mention also that there is a graph up here, but it's just not showing on the camera because it's bright. I'll work out for future demonstrations, see if I can make that black or have a different contrast there. But it's graphing it, it's showing. But you'll always notice, the other thing I wanted to mention when we're talking about temperature wells, setting up temperature measurements, you also have to get to know your standards. I've had wells that will heat up maybe 10 degrees over before it will settle back down. And there are sometimes settings for that, but sometimes there's not. It depends on how current your standard is. One like this, it has a set amount of time that it's gonna sit at temperature before it shuts off. But that time starts after it has settled. So other ones, it's gonna, it might get up to temperature or get over the temperature, maybe 5 degrees, 2 degrees, and then it's going to settle back possibly down under and then bring it back up. So some of the characteristics that you just need to be aware of, sometimes those temperature wells will not be perfect.
Analogy would be like our stove. You know how you set it to like 400 degrees and start, but it has a preheat function on it. And
Right.
then when it comes up to temperature, it's ready to cook, and that preheat goes away.
Exactly.
It's funny how a lot of the stuff that we use in our home is directly related to things that we use in laboratories.
Oh yeah, for sure. Oh, I don't know if you heard that ring. That's what they use for saying that it's stable. And we stabilized at 99.93. I notice a lot of these will stabilize within, that first decimal. I think there's settings for that type of stuff where you can change where it decides it is stable. But 99.93 is extremely close. And you would expect on the readout to see 99.9. It looks like we're still climbing up. I will, full disclosure on this demonstration, the thermocouple that's in there is one of the ones that we did some, buy from Amazon and see how good they are in a previous demonstration in our school. And it's been through the ringer. I think that thermocouple's been up to 1200 degrees. I think that's one of the ones that 1200 degrees Celsius. I think that's one of the ones that I had some fun with. So what do you think, Joseph?
I think it's good. I like it. One of the things, the other aspects that you're talking about is the composition of the probes on the very tip. Some are
Yes.
grounded, some are floating, some are seated. So that's important to understand what type of probes that you have that you're using.
Now we talk about that in the school, but since we may have people watching it on YouTube, so explain the type of probes there, the differences.
Okay, and thermocouple probes, I mean, besides your just bare twisted pair, and you might have a bead that's, fused on the end, many thermocouples come in shielded sheaths, like the one that we're using today. And so, for different reasons, and I'm not going to explain here because it takes a lot of time, but it is in our text. You'll at the very end there's a, we'll just use this tube as so this, consider this the sheath, and then there's a wire that goes through it. Well, at the very end, it can be grounded to the sheath. It could be floating, or it could have another situation where it's encompassed all around by the sheath. Now, this isn't thermocouples. There are other temperature devices that are totally different. Then there's things that are just unique to them. But just thermocouples, if you see the probe, it's a stainless steel probe, looks like a thermometer, kind of, sort of. And they come in different sizes. I've seen them short, and I've seen them, 20 inches long. So, or even longer. I've seen them like 3-4 foot long.
Oh yeah, I even have a 20. I think it's a 2 foot long thermocouple probe in here. I got this one's a pretty decent length one. Hey, so another thing we want to talk about is insertion depth, Joseph.
Mm-hmm.
So insertion depth, in reality, it goes back to what you're talking about, that flow from hot to cold, right? Because if we have too much cold probe above our temperature well, what happens? Do you want to talk about that?
It won't ever stabilize. And I'll give you a good example. We're doing a test on a probe that goes down to minus 20 degrees. The problem was that the probe body that they were using, the standard they were using to check the temperature, stuck out of the aperture, a good 36 inches. So you have essentially what you have is you have a sink, a temperature sink, and
Right.
it just draws the heat away from the tip of the probe, because the tip of the probe is the insertion depth. I mean, it's not really, the whole probe is not the temperature sensing device.
Right.
It's just at the tip end.
No, yeah, good point. And typically you would take that actual probe. So they would tell you what the sensor size is. Like usually a manufacturer, when you buy a good quality probe, they'll say, hey, it's a 1 inch sensor or whatever size it is, right? And then you have your probe diameter, which they recommend. I mean, this is a general rule of thumb where you take that probe diameter. So if we have like a 1/8 inch probe, and then you multiply that by 15 is usually the way that people calculate the insertion depth. What
Mhm.
that typically comes out to is around 4 to 6 inches. I mean, isn't that pretty safe to say?
Oh yeah, 4 to 6 inches at the max. Yeah.
And when I was holding up that well insert, everyone saw, it was what, right about this depth. And so that's going to be your average size for most, we'll use our air quotations, normal temperature probes. So hold on, let's look at our sensors now. Let's see what we got. Let me go walk over there, okay? All right, so where are we sitting? So now we're at 99.9 and 99.9. So most likely this is a ungrounded probe. Most likely, because of how long it took to stabilize. If it was one that was grounded where it's touching the sheathing, most likely it would have been very fast. Just for kind of a reference, I'm going to put in one that's just a very simple thermocouple where I've just connected these. This is what you're going to see all the time out in the field, people measuring. This is a thermocouple to them, and it's not. Everybody should know that. But here, I'm going to hook that one in real quick. So let's look at the difference in response time for that one. Does that make sense?
Yeah. I would like to say that there's probably a good portion of people in their kitchens that have thermocouples and they don't even know what it is.
Oh, yeah. Yeah, for sure.
Those, like I have one for checking the meat temperature, 165 degrees, it's done, you know.
Yeah. Yeah. And your oven, some ovens are thermocouples, some ovens
Hmm.
are RTDs. Depends on the quality of the oven. But we notice, look, it's already almost up to that stabilization point. So definitely quicker when you're using something that a thermocouple that is exposed to air.
Yeah, there's no worry about transfer of heat and sinking of cold and stuff like that.
Exactly. So like we were saying, this is an example of a dry well thermocouple calibration. And it's super easy because you just go to the next test point, whatever that is. Once you get your measurement, and where are we sitting now? I have to put it larger. I can't see that small. So 99.6 on our makeshift thermocouple. And so
Yeah.
it looks like it's going to stabilize up there.
What's
And
our
and
spec
and oh, go
point
ahead.
two? Our
What?
spec is point two.
That's for the well. The well
Okay.
is spec to point two, so it's
Hmm.
way accurate for that. It's accurate enough to calibrate some RTDs, some 3-wire, because the 3-wire RTD, some of those have don't some of those have above a half a degree. I shouldn't even say that if I'm not looking at the standard.
No, I think you're right.
I
I
think
think,
some of those go up to a full degree. But another thing I just thought of that I wanted to mention, when we're looking at this, and notice how I just did our quote unquote makeshift thermocouple. And I highly discourage anyone from doing that very often if possible. just because you will get oxidation, even though it's as tight as you can put those together, if you're doing it yourself. If you've got wire, the wire tools, what are the ones that, what did they use to do aviation wiring? What are those things called again? They have that spin the whole thing. Have you seen those? Safety wire, the safety wire pliers.
Oh yeah, safety wire. Yeah.
Safety wire pliers.
That,
even if you have something like that will make it super tight, you're going to get oxidation in your thermocouple junction.
Yeah,
with ones we put together like that.
I'd like to throw a caveat in there real quick. We're talking about getting that junction tight. Never solder those units together, braze them or anything, because it's the Seebeck effect is all about 2 dissimilar metals, not 3. So
yeah, you're going to be adding in another measurement.
It'll read out, but it just won't be what it's supposed to be.
Yeah, the error will be, that's adding to that uncertainty.
Yeah, you have to clean those wires, you have to twist them together. We call them gas tight twist. And there are some manufacturers that will put a little bead on the end, but that's done at a very high level in a laboratory and stuff. If you're making your own, which I don't suggest either, but you get your finger oils and contaminates on there, and then after holding it for a while, it'll just loosen up anyways.
Yeah. I mean, you see it a lot in real practice with places that just don't understand, and all we can do is try and do our best to make it, do the right thing when we come around and make sure that they get because a thermocouple isn't expensive. It's just, this is a shortcut. But I will say there are times that you need that super fast response time. And so that could be an appropriate time to do something. For you to do something like that, I'm going to take that. Sure. I'm going to take that one out.
What do we call that? Field expediency?
Exactly. And then, like we were saying, the other way you would calibrate these, a readout like this, because sometimes a customer is just going to ask you to calibrate the readout because there's no way of actually, accessing the thermocouple or removing it, or, whatever reason they may have, and they're willing to take on that risk. You'd actually just simulate the voltages to the back here where the thermocouples actually went in. So right here. But I always warn everybody, you're not going to be able to turn these off all the time. You're not always going to be able to secure power. And look where line voltage is coming in, right next to your thermocouple. Always. So you got to be super vigilant. Watch out for yourselves, especially when you're doing on-site stuff. But that's really the basics behind what a source is. Something that can achieve a temperature, stay stable. It can be many different types of medium. Here's a dry well, so it's basically metal on metal with a little bit of air in there. But then there's stirred liquid bath, which is probably the best type of media to use, or the best type of well or temperature source, I should say, would be your stirred liquid bath. Wouldn't you agree, Joseph?
Yeah. But there's a lot of peculiarities to stirred liquid bath. So when we get into that, we'll explain that.
Right. All right. Well, I noticed we had a few error messages during our stream about our bit rates and things. So if any of our video was messed up or audio during this, it looks like we have it all handled out now. But thank you for tuning in. Hopefully this will be much more regular and much more or much less technical difficulties. But I think we still got a decent demonstration out there, Joseph.
Yeah, I'm happy with it. For that small piece of information that we're putting out, I think it was really good.
And then, so I kind of decided, because no one's using our YouTube chat, but people are using the school chat. I don't know if I'm going to get rid of school chat and have everybody come over until we have the school chat is supposed to take priority. But right now we don't have any competition. So why have two different chat sources, But chat had a quick question. Are we going to be doing when are we going to be doing the barbecue special? Good
Yeah.
question. I think I'm going to be doing the barbecue special maybe this month or the very beginning of July, where we compare. I have like 5 different types of temperature probes for meat and all that. Here's one right here. An example of one that I tested. This is a, a therm pro is what it's called. And see, this is a meat thermometer. I don't know if you guys can see that here. I'll bring it on the other camera. So that's a very pokey probe, that goes directly into meat for monitoring. Do you have something similar, Joseph?
I don't have a barbecue like you do. I just have a small, Weber, but
I'm a little into it.
I do have a probe, and if you watch any cooking shows or anything, you'll see people use probes to say, oh well, make sure the meat is 165 or whatever it is for
Well, it
that.
depends on the meat. That's for
Yeah,
chicken.
yeah. I saw last night. I'm from Sicily, and in Sicily they make steaks that are like this thick, and all they do is braise them on both sides for a couple minutes, and the preferred serving is rare.
Yep. Well, I think people are going to be surprised with the accuracy of some of these things. I also did like a mouth thermometer, some other things. So thanks for the question. Yeah, we will definitely be doing that. See if there's anything else that we should answer before. Oh, one other thing. One last little announcement. We have somewhat announced this, but if you're watching this, you'll get another pre-announcement before Wednesday. Wednesday, we're having our huge announcement publicly for our certification test. We want to make sure everybody's aware of that. The next 50 people that enroll in our school between now and August 31st will be able to get the certificate. Will be able to take the certification test. They'll be able to have one attempt for free if they enroll before August 31st. We would love to get a bunch of people on this. I hope some of you watching are interested and want to enroll. This is exciting because this is finally a certification test, Joseph, that you have an idea that the person knows the concepts behind calibration in a certification test. You know that they know what they're supposed to before they're touching your equipment. And that's even for customers.
Yeah. Oh, yeah. If you go to a doctor and you say, "Are you board certified?" that's what you expect. So, I mean, not saying we're doctors or stuff like that, but once you get the certification test, there will be some reasonable thing to say that, okay, you do know what you're talking about.
Right. Confidence. That's what we put on our website. The certification link on our website, calibrations.com, is updated, so you can go there and start looking at what we're talking about. And I'm just really excited. So we're going to be talking about that more over this summer. So that will be a subject that we talk about here on the show as well. Why do we need a certification? And people that have been around don't need that question answered, but some of you that are newer to the field might not understand why. Why is that an important thing? So we're definitely going to be talking about that over the summer. We even have a podcast with some of the people that helped design this test. So it will be great. Over the summer, we're going to be teaching everybody about calibration, metrology, and then also the certification.
And that'll be a good one for supervisors, managers, and business owners.
Oh, yeah. Yeah, trying to find qualified people is very hard these days.
The whole reason for this course.
Exactly. All right, Joseph. Well, that ends our Monday morning metrology for June 14th, Monday, June 14th. It was good to have you on, and hopefully we got all of those technical things ironed out, and then we will be set for the rest of the summer.
Yeah, and don't be afraid to call us or let us know if there's something specific that you want to talk about. something that bothers you, feel free. That's what we're here for.
Oh yes, we're starting the confessionals maybe next week or the week
Oh yeah,
after.
yeah.
Yeah, I don't know if we'll fit it in next week, but the week after we'll definitely start some of the confessionals. Some of these stories are gonna crack people up. So
Or
and they're gonna
or scare you.
piss people off. Yeah. Well, Joseph, thank you, and we will see all of you next week.
Yes. See you soon.
All right.